Let's click the calculus, go to continuity and one-sided limits. And of course, this is going to be off the screen, but I'm over here and I'm going to be clicking on 23. I believe that's the one we're going to be working on. Wow, we got a lot of stuff going on here, it looks like. This one here says we want to find an A and a B that makes f of x continuous on the entire real number line. We want to find an A and a B. We can do this. So what you'll want to do is jot this stuff down, and I'm going to give you some time to do that because, well, I'm doing that. And I honestly think that you should do this. Right? Write this stuff down. 94, x is greater than or equal to 11. Okay. Did you get it? I got it. So we're going to find an A and a B. Let's, hope you got all that. Well, here's our piecewise defined function. This time it's in 3 pieces. We got 22, and x is less than or equal to 2. What else do we have here? We have ax plus b, where x is greater than 2 and less than 11. Less than 11. Then we have 94, and the domain of this guy is x is greater than or equal to 11. Right. So what we want to do is just go through and do the same exact procedures. Don't let it confuse you that there's 3 of them. And the way we're going to do this is okay, the 2 places on the graph on the x-axis we're concerned about is 2 and 11. Right, so we want to make sure it's continuous, where it meets up at 2 and where these 2 guys meet up at 11. Alright, meet up at 11. And that ain't 11 o'clock. Okay, so the first thing we want to check is f of 2. So f of 2, and that's going to obviously be that guy right there, 22. F of 2 is 22. And then we have the limit as x approaches 2 of f of x. Now, we have to check, I'm going to continue this right here. We got to look for the limit as x approaches 2 from the left hand side, and that means that we're going to be using x is approaching 2 from the left hand side. That means we'd be using this one here, right? All x values less than 2. So that's just a constant 22, and of course the limit of a constant is just the constant, okay? And then we have the limit as x approaches 2 from the right hand side, and now that's going to be this one here, okay? x is greater than 2, and of course that's ax plus b. We're going to go ahead and do direct substitution, so we end up with 2a plus b, 2a plus b. Now that all that's said, these two must be equal to each other. So we're going to get an equation, and let's write that equation. Right, running out of room here. Let's go ahead and just write that equation down here, okay? So 22 is equal to 2a plus b. All right, 2a plus b. Okay, good enough. All right, what we're going to need to do, since we have 2 unknowns, we're going to need another equation. And we're going to get that by looking at where they join up at 11 now. So I'm going to do that, draw a line right there, draw a line. And let's now do, let's say if we had f of 11, what is that going to be equal to? Well, what happened here? This is 11 right here. It's like it's morphed into an M or something. This says x is greater than or equal to 11, okay? So that's actually equal to 94. That's actually equal to 94. Then we're looking at the limit as um, x approaches 11 of f of x. And of course this is going to be the limit as x approaches 11 coming in from the left hand side, and that means we're going to be using this one up here, right? We're going to be using this one up here because its x is less than 11, and that means ax plus b is equal to, and then we just do the direct substitution, so we end up with 11a plus b. 11a plus b. Okay, and then we got the limit as x approaches 11 coming in from the right hand side, so this is x is greater than or equal to 11, so that's going to be 94, and that is right. The limit of a constant is just the constant. And now we have to set these two equal to each other, and we'll do that right here, and we'll say 94 is equal to 11a plus b. So now we have two equations and two unknowns, and we can solve for a and b. Okay, now we'll just do we won't get fancy with this, like put it into a matrix or something and find the inverse and all that. What we're going to do is we're going to just do a substitution method here, where I'm going to take this one here, go 22 minus 2a is equal to b, and then we'll take this and plug it into here. So we have 94 is equal to 11a, and then plus 22 minus 2a. Alright, we just plugged our b in there, and now we can go ahead and solve for a in this problem. So 11 minus 2 is 9, right? 9a, and then I'll bring that 22 over, so we have 94 minus 22, and my nose is itching. We have 72 is equal to 9a, and of course a is going to end up being equal to 8, right? Is equal to 8. So we'll put that. So we finally found our a. Now to find our b, we can just go ahead and take this one here and do 22 minus 2 times 8, and that will be our b. So that's pretty easy to figure out. That's going to be, and I like to write it like this right here. So b is equal to 6. This is our b actually. So b is equal to 6, right? 22 minus 16, 6, is that right? Okay. Oh my gosh. So guess what? We found our a. I'm going to write it nice and big right here, 8, and we found our b, and our b was 6. What did we have to do? Ugh. Well, we just followed the simple steps, right? It seemed like this wasn't even necessary right here. You know, the whole idea was to get the left and get the right, like we did here for 2, where 2 meets up. Then we set these guys equal to each other, and then we looked at where 11, where it's going to meet up at 11, taking the limit of f of x as x approaches 11, set those equal to each other. We ended up with two equations and two unknowns, and then we just do some simple algebra to find out what our a and our b is. Okay, and I believe I had a is 8 and b is 6. A is 8 and b is 6, yeah. And then of course you can go through there and plug that in. Plug in 8 here, 6 here, and then test it out and see if it works, and it better work. Anyway, that's a more difficult problem. It's an easy one with three equation, or with three parts pieces, but they can get a whole lot more difficult than that. Okay, I'll see you there. Bye.